So this has come up before. I think it's been a warm-up. I think it's come up in our class. I've discussed it repeatedly by now, I think. But I want to make sure that we've got some clear notes because it's going to lead us into other goals. So what makes the earth warm? And people will often say the sun's heat, and that's incorrect. The sun is really, really hot, but you got to get really, really close to feel it. Like if you're in outer space heading toward the sun, it's really cold. You leave the warm earth, get to really cold space, approximate the sun, and then you start to feel the heat, and then you evaporate. Because it's really, really hot, but heat doesn't travel very far. And some people think it's the lava, the magma underneath the ground. And that's also really, really hot, but heat doesn't travel very far. So no, that's not the source of the Earth's heat. The source of the Earth's heat is sunlight. Now, some of that light is reflected because some things on our planet are shiny, like ice and water and ice crystals. Clouds are kind of shiny. The surface of waxy leaves is shiny. By the way, study goal number 18 really quick, that's called albedo. So that's how shiny something is, shininess. Albedo is shininess. Ice has more albedo than dirt. Dirt is low albedo. Maybe you know, some colors are reflected. If you're looking at all wavelengths of light, you're looking at the color white. White is the sum of all the wavelengths. So things which are white don't absorb any light. They shine it all back to you. That's why white stuff is cooler, like a white sweatshirt or a white car, because the sunlight is being reflected, not absorbed. You add up all the visible spectrums of light, and that makes white. White is blending the rainbow. That's why white cars are the coolest. Not like cool, but like temperature cool. Black is the absence of light. So things which look black to your eye, like my sweatshirt, have absorbed all wavelengths. And that's why a black car gets hotter, because it has absorbed all the wavelengths, and thus it's generating more heat. So albedo is study goal number 18, but back to this, dark things on our planet don't reflect as much light. They absorb the light, and then they, can't make energy or lose energy. That's just got to go somewhere, so that becomes heat. The source of our Earth's heat is the Earth itself. The Earth absorbs sunlight and gives off heat. Looks like this. Remember that some is reflected by the outer atmosphere, some is reflected by the clouds, some is reflected on the surface, but some of that sunlight is absorbed, and the sunlight which is absorbed is re-radiated as heat. I think I've seen this number on an AP test before, so let me clarify really quickly. Of all the incoming radiation, that's all going to be accounted for somewhere, right? We're not going to make or lose any energy. So some is reflected, some is absorbed in the air and absorbed on the surface. So that adds up to 100 units, right? Of that incoming radiation, 30 is reflected and 70 is absorbed, okay? Of that 70, it all becomes heat, but on the way out, some heat runs into greenhouse gases, and that comes back. See, that's what we keep. The key concept that I need you to remember in number 16 is that this is one of those thermodynamics things. Energy is not made, energy is not lost, it just changes form. Sunlight changes form to heat. More albedo, you get less heat because you're reflecting more of that light. less albedo, you're absorbing more, so you're going to get more heat. My sweatshirt has low albedo, so if I go out to the sun, I'm going to feel a lot of warmth coming off my sweatshirt. You can feel it from outside. That's not my internal heat trapped. That's the sweater itself heating up, right? Like I could crumple this up and leave it on the table, and it's going to heat up more than a white sweater crumpled up on the table. All right, that's it for 16, but we're going to come back to talk more about this.